Okay, good afternoon, everyone. Today we have Pajelmer. Pajelmer, where are you? Okay. All right. All right. Apparently, Pajelmer is still occupied. Then we will start in 5 minutes. So please stand by, everyone. We will be coming back. Maybe we can start taking the absence for today. All right. There you go, Pajelmer. We were looking for you.
Hello, everyone.
All right.
I took the privilege to get some
Okay,
coffee.
Pajelmer. Time's yours.
Okay. Good afternoon, everyone. Today we'll have the parenting course on how to prepare our children for the future. And today we're gonna take a look at the things we can do at home with our children. We already spoken about the academic choices which they can probably bring us. Today, for the next couple of 6, 7 months, we will still have a lot of time with the kids at home. Maybe even until the end of next academic year, that the schools will not be fully open again. We don't know how things will go. Some countries already opened up their borders again. The kids are going back to school, and they have seen a increase on children and parents who are getting sick. And well, obviously, Indonesia doesn't want that, and we are still looking at what is happening in other countries, and hopefully, we will not make the same mistake here. So, today we are going to take a look at things we can do at home. Oh, I need to keep this one up because I need to share the screen. Okay, I have a nice PowerPoint file. Here we go. Okay, equipping for the real world, how to get our next generation interested in science and engineering. These are some easy and fun activities we can do at home. Now, for all the activities that we do at home, the children will always need our supervision. The things which I have found for primary students, they are quite safe, but still, kids are working with things like glass and water. They can slip and fall, and we don't want our children to have any damages or getting injured. It's not comfortable at all. Okay, today we're gonna take a look at the four main sections of science and engineering, looking at math, chemistry, physics, and biology. Now, I haven't put things like computing in it because most of the students at our school, I think we have a total of 4 or 5 in my class who will take computing, and this is something which the kids really need to like. And us as a generation of parents, most of us are not really good at programming, so these are things which we normally do not do at home. So we're taking them through step by step: math, the games in math; chemistry, what kind of tricks we can do at home, what kind of things are favorite on the YouTube; physics, is it all abracadabra? Is it all so difficult, or can we do stuff at home as well? And of course, biology, working with our beautiful nature. Now, mathematics, the most boring class at school. Every time I start mathematics class, let's say I have 10 students, 9 of them have a face of depression. Number 10 doesn't know that it's math class. The face of depression will come a little bit later. Now, math by most students is not liked at all. Students, especially going to the higher grades, will not enjoy math anymore. Until grade 6, 7, it's still doable. And once we start with algebra, students are starting to having problems. Instead of scoring a 90 on their test, all of a sudden they score 70 and they are not motivated anymore. They lack the motivation to keep on studying. And math is a subject which needs practice. If you, as a young student, start to practice and keeping this practice up for a longer while, you will notice that when you grow older, math is a lot easier. I notice when I'm in class here and I'm teaching grade 10 that I can do almost every calculation without a calculator. Most of the things that we do, I do not even think of grabbing the calculator. I do stuff in my head and I make a question on the board, which is also already in my head. And I'm hoping that in time, my own students will also learn to do more of head calculations. But I cannot just start with this when they're 14 or 15. We cannot start with this when they are 12. We need to start when they are young. A brain, we can look at it as a big muscle, and we need to exercise it to have less of a headache if we do other stuff. If you go out running, you haven't run in a couple of months, the first time you are tired, your muscles are sore, everything hurts. And doing mathematics is exactly the same. If you don't practice it and you start to do mathematics again, you will get a headache. Things will hurt, you don't like it anymore, and you don't want to do this a second time again. So, now, when to use math after our education? This is a question which I ask myself so many times. I know at school I've had calculus, which was a horrible headache. Even for me, it is not a thing that we will like. And if you start to study engineering or any of the other math or physics subjects, you will need to do calculus. And the calculus is a problem for most of the students. Algebra is a problem because they didn't practice how to manipulate, how to change sums, how to look things in a different way. The door doesn't open from this side, so we need to open the door from the other side. And we need to change our movement. And mathematics does exactly the same. So, to be really fair, the first time I used mathematics again after high school, and not like in college, not for studying, the first time I actually need to use it for my work was when I became a teacher. For everything I did with engineering, I have a computer. I type in a couple of numbers and I don't have to do anything anymore. The computer makes us lazy. And I noticed when I came back to high school here that some of the things were not practiced anymore. Multiplying fractions, for example, simple plus and minus calculations. Because I didn't practice this anymore, my big brain muscle didn't work as well anymore. And I was teaching in grade 3 and I'm doing something with fractions, and I was like, oh my, I forgot how to do this. And a quick look on the internet, a quick flash of light in a part of unused brain, and it got me back into shape again. Now, still, for certain things, I still need to look on the internet. I still need to check a little bit what's the best way to explain this, what's the best way to teach this to a kid. Are there some tricks I can use? Now, YouTube is full of these things that we can find a lot of help. There are many teachers, especially nowadays, who give extra lessons, who make channels, and they help us and me as well with teaching subjects for when we have children at home. Now, when to use math after our education, many kids will ask it. Shopping. You are in the shop and you have things like a discount, losing a percentage of something. You have to you have two products, each has a different weight, and in ratio we need to find the price. For which product do we get the most for the least amount of price? And this is a bit tricky when you're still in grade 1 until 6. On grade 6, 7, 8, 9, and 10, You need to be able to do this by your head. Yes, as an
Hello.
let's say I want to buy chocolate. I have 3 bags of chocolate from which I can choose from. And all of these bags have kind of the same price, but some have a different weight. For which bag of chocolate do I get the most amount of chocolate for the money I spend on it? Things we use it as well are travel speeds. We need to go somewhere. We need to wait somewhere for a train or for a bus. We have different time schedules. What can I do in between? Can I take a walk? Can I have a lunch break? How long does it take me to go to another place? What was my average speed? How much oil and gas did I use? Can I save oil and gas? And these travel speeds and distances, we look at this as well. Now, time management, of course, when we do things, when we start to work, we need to manage our time. You will use math with this every day. How many can I produce in an hour? If I can produce 50 in an hour, that means I can do give and take one in a minute. If I need to do 15 things, it takes. And this time management is also still used by us as teachers. We need to make post tests. How long do we take for a post test? We manage the time on how we need to teach. How long do I teach to? How long do I need to teach English? How long does it take me to explain how punctuation works? And we still need to use time management as a math skill. Now, some games to make math more fun for students and children. Now, for children, I actually mean the youngest one under us, kindergarten, grade one, two, three. They are not good in making mathematics yet. They didn't have that practice yet. But if we play games with them, if we can get them to do math in a subconscious way, that they learn by playing, that would be the most perfect thing. They are playing, they are nice most of the time when they're playing, unless they lose. They have an activity, and at the same time, they are learning as well. Now, the first of the games is a math bingo on the next page. So you can go there. With math bingo, we fill up a chart with numbers and we give our children a small calculation and they need to find the answer. If they find the answer, they can put a marble on it or they can put another token, something small on that number. And if we do this with kids, some of them might get 5 in a row and they have what we call bingo. So the kids need to do a calculation, find the number on the chart. Do they have the number? Maybe they don't have the number at all. And in this way, they play with each other. Now, if we go to higher grades, give and take grade 4, 5, and 6, we can make this as multiplication. We give certain numbers, let's say 24. And instead of pulling out a number from a ball, we take out 2 times 16. 2 times 16, 32. Is 32 on my chart? No. Next card, 8 times 3, 24. Is 24 on my chart? Yes. They find number 24 and they put a token on it. In this way, we can let kids play with each other, play and learn at the same time. And this is important to get them to have more joy in math. Math is not the most fun subject, and to get a student prepared for this, to get a student into math is a problem for some of us. Now, some other thing we can do is math memory. With math memory, we are making memory as we normally have it with pictures. All the pictures are upside down, and one by one, we need to turn around to small pictures. Now, this is already a challenge for younger kids. Remember gotten beaten by my younger brother. My younger brother is in grade 6 now, but in the Netherlands, it's the last year of elementary school. But when he was younger, he beat me at a game, and I noticed that when I let him start, that he has a big chance of beating me. And he was 5, maybe 6 at the time. I'm already living here for 5 years. So I got beaten by a young kid, and I felt kind of sad. Sad that I didn't know my memory anymore. I didn't focus, and sad that my little brother beat me. And on the other way, I was really proud. Proud that such a young kid can do this already. And if you practice memory, with your kids, you will notice that in a while, they will become quicker than us. They are better at memorizing these smaller things. We need to, as parents, memorize chess. We need to memorize how to do stuff. And the kids' memory is still much more focused. Now, in math memory, we don't have pictures on the other side. We have a little calculation. Let's say on one we have 2 plus 4, and on another one we have 12 minus 6. And both of them give us the answer 6. So we need to make groups of each answer. So, for example, we can make 25 groups, or we can make 20 groups, depending on how large you want to make your game. If you have more than if you have more than one child, you can make a bigger game. If you are only playing with your child, a game of 10 is more than enough. So, in this way, they learn how to do memory and they do math as well. And together, we can assess two skills with them. And the third one, they enjoy it, they can win. Try to lose from your kids a couple of times. They will know all the calculations. After you've lost on purpose, try to win from them. And you will see that you have a big challenge of beating your own kids. Now, a thing more for secondary students is 3D art. We already teach our students how to make cubes and rectangles, cuboids, spheres, cones. They know all of the 3D figures. But what students miss is the ability to draw these figures. Now, in 3D art, we can teach our students how to draw certain figures in a 3D shape. I can show it later, but we have two of these ways how to do 3D art. We have the perspective way, the way how we look at things, and this has more to do with drawing. And we have the mathematical way in which we expand a certain shape into the z direction. We have x and y, up and sideways, and the z direction is for depth. Now, I'm gonna take this away to do, and I'm gonna share a screen with you. I'm gonna make a new share, and I'm gonna start a whiteboard. Now, as you can see on my whiteboard, making a 2D shape isn't that hard. We can easily draw a rectangle. It's easy to do. Oh, we can easily draw another rectangle in the same shape. If we connect these two rectangles with each other, should actually use another tool for this. You can see that we can make 3D shapes already. We can learn our kids and the students to draw 3D things in a really easy and fast way. Here we have a cuboid. How long did it take me? 10 seconds? 15 seconds? We can also teach them to make other shapes. Now, the rule in mathematics for this is we go sideways by 2 and we go up by 1. So we can actually teach them this by giving them a small rectangle of 2 by 1, and they need to draw a line from one side to the other side to make it in 3D. Now, I'll take this away and I'm going to show you how to do this with a different shape. Let's say, for example, they want to do this with their own name. Let's say one of them is as the first letter of the name is an E. Now, this is quite quickly done. How to make the letter E in a 2D shape, in a 3D shape. Now, once you learn a student this, they will love it. They will make all kind of letters in a 3D shape. From every spot we can see, we go, oh, then take it, we go two to the right and one to the left. We keep the same ratio. Now, it will not look perfectly because I'm on a PC. We'll keep the same ratio everywhere. That one was horrible. And you can see that we can make a 3D shape in just a couple of steps. Now, younger kids in grade 1 until 4 will have a little bit of a problem with this. But older kids can make beautiful 3D structures with any shape given to them. Now, the letter E is a nice one to see because we have different sections. Now, letting a student learn how to draw in 3D perspective for mathematics is not that hard. In a couple of steps, we can do this with them. Now, my own daughter is still too young. She still draws like a monkey. It looks like nothing. She cannot draw any shapes yet, and I'm slowly teaching her how to draw the letters. But hopefully, in a while, I can teach her this as well. Now, this is called Mathematic 3D drawing. The other way how we can draw in 3D is in a perspective way. And for the grade, now, give and take, we go to grade 7, 8, 9, and 10 to teach them how to draw in 3D with perspective is a lot harder, but it's still doable. We draw a horizon, and on the end of the horizon, we have, let's take another color. And at the end of our horizon, we have two dots. It's the end of our view. Now, let's say I want to make a 3D shape, and here I make a 3D shape of a cube, and I want to make it in perspective. So I draw a line not equal on both sides, because in this way perspective is nicer. We take a line from the top and go to the black dot at the other end. We don't go all the way, we pull it a little bit back. And from the bottom, we do exactly the same. We take a line which should go all the way to the left, but we don't, we stop halfway. We make an interconnecting line between the two ends. We do the same on the other side as well. We take a line from the top all the way to the black dot at the end, but we pull it backwards. We don't want to draw it all the way there. We do this with another line, and we connect them together. Now you can see, if we take the horizon away, that we can make a shape in real-time perspective. And it's actually not that hard. We can teach this to our children. It takes me a couple of minutes to teach this. If we spend, give and take, half an hour, we can make much nicer shapes. Now, let's make this one a little bit bigger, and you can see how much we can do with this. I'm taking the inside shape all the way until the end. And I do the same from the other side. And I connect them with each other. And I make another shape on the inside here. Now we have a 3D figure with only the bars. Drawing in 3D is not so hard. But once kids learn how to do this, they can make many beautiful things. Let's take a few of these steps away. Let's take this away. It looks like a piece of metal which we use for constructing gypsum walls. Students can become really creative with these things. I learned this when I was in first grade of high school, and I'm still using it when I draw machines. I still use this skill quite often just to show kids how easy it is to make something look really pretty. It's just a couple of lines. But for students to practice this when they are young, they will only become better. And in the end, they will become even, well, hopefully, better than me. Now, let's go back to the spreadsheet. Now, these are things which we can do with mathematics with our students. So, is math boring? No. In my opinion, no. We don't only have the numbers in math, we have many more things. It's trigonometry, it's not only solving a puzzle. Mathematics has to do with prices and change. It's not only the numbers. Math can be fun as well. Let's go back to the spot where we were. Now, the math bingo, make a chart, 5 wide, 5 high, 25 spots. Fill it in with random numbers on the 25 for lower primary and kindergarten. And if we have all the students fill all the 25 or maybe 36 spots with multiples under 100. So they can study more how to do their tables. And let's say for secondary, we can even make them with algebra. We give them a little sum in which they need to find the algebraic number for a letter. And in this way, they will practice their algebra. They will become a little bit better at this. It's actually still the same thing which we do at high school, at the elementary school. 6 times the black spot is 42. At elementary school, we already learned that we can turn this around. 42 divided by 6 will be the black spot. But once children get to grade 7 and grade 8, all of a sudden, this view on having a black spot somewhere and changing it with a letter becomes hard. But it's just as simple as turning a formula around. 3 plus 2 is 5, so 5 minus 3 is 2. And if we teach this to younger kids, that changing it for a black spot or a ladder actually means exactly the same, once they reach grade 7 and 8, they will have much more fun at doing math. Instead of scoring 70, they will score 90. And it makes them more happy doing math. And well, when they come to grade 10, all that happiness will go away because math will become really difficult, not mentioning grade 11 and 12. Now, for students to get them to appreciate math is one of the hardest things there is. Now, the math memory creates small cards. Each card has a sum or function, and each answer should occur only twice. Students flip a card, solve the question, flip another card, and try to find the two equal answers. Now, let's go to chemistry. Chemistry is the subject of puzzling, ratios, change, and reaction. We use a lot of mathematics in chemistry. Maybe it might not look that way, but every chemistry element is a combination of certain things. And in a special ratio, it will react with something else. So we use mathematics here as well. Now, when do we use chemistry? Cooking, cleaning, preserving food. Oh, it needs to be preserving. Now, for cooking, we make something warm. We have changes which happen in the structure of something because we are making it warm. The pan will become hot. Why, if I stick a wooden spoon inside the food, the wooden spoon will not be hot. And if I stick a metal spoon in the food, the metal spoon will be hot. Conduction of energy. This has to do with chemistry as well. Now, activities which use chemistry, doing the dishes and cleaning a dirty spot. For a kid, we can let them do the dishes, we can let them play around. We can let two of them clean a pan, and we give one of them warm water and some salt, and the other student cold water. And we can see that the pan, which is using warm water and soap, will become a lot cleaner. Water and ice, condensation and melting. Now, all the students know, of course, when we put ice somewhere, in a while it will become a puddle of water. But what if we put salt in the ice? Will it melt quicker? Does it make the water warmer or colder? It's a nice trick to show the kids. And of course, our glasses of drink. Where you're sitting somewhere, sorry, we have a glass of cold drink, and all of a sudden there are bubbles on the outside. Where does this water come from? Does the kid know that it's not leaking through the glass? What is happening? We can explain to students that the glass is really cold. And all the little particles of water which are in the air, they become slower and slower because they're slower and they come together and they make a bubble, a water, and a drop of water. And this happens also in our weather, where a cloud will be rising, the air will cool down, the water droplets do not move much anymore. They hit each other, they stay close to each other, and they fall down again. We can teach our kids how this works. The change of matter is something we do in heating something. Let's grab a couple of kids and let them hug each other really tight. And this is a solid. They are they cannot move quickly. Now let the kids move a little bit. We will see that there will be a little bit of distance between the students because they are moving. This is our liquid state. Now let them hold their hands together and let them run away like crazy. What happens? The bonds between the students break. It turns into a gas. Instead of the particles being connected to each other, they fly away everywhere. And we can teach young students in grade 1, 2, and 3 already how change of matter works. Now, of course, chemistry is much more than that. Chemistry, students always think like, let's make a bomb, let's throw stuff together, let's make a lot of foam. Now, on the next page, I have a couple of videos on this, and I want to talk to you as well about smoke bombs and little rockets. Now, when I was a student, give or take 12 years old, every year during the new year, I would make a bomb, and these bombs would become bigger and bigger and bigger. The first year, I would blow up a microwave. The year after, I have a whole barrel of oil and benzene. And in the last couple of years, my parents were really worried about what I would do next. Now, is it bad to be naughty like this? Now, the problem is, as a kid, you want to explore, you want to look for limits. And it's not bad to look for a limit, but we also need to teach them what a limit is. If we come and take a look at our kit and it sprayed itself in benzene and it would see if it could extinguish it and everywhere burn marks and that kind of stuff, we are too late. Yeah? So when they play with these things, when they play with chemistry, even soap can react with our skin as well. We need to be careful with what they do. If they want to make a little smoke bomb, it is still using fire. It is still something which is dangerous. So we need to teach our kids to work and to play in a safe way, especially chemistry. Now, a nice example for this is what I show the kids in grade 7 and 8 is how acid works. We have a sulfuric acid here at our chemistry lab, and I tell them, well, what happens if you get sulfuric acid on your skin? And all of them answer the same thing, yeah, put some water on it. I put water on the sulfuric acid, and we have a big bunch of steam because those two react a little bit with each other. So we cannot put water on it. What should we do? Learn the kid how to work safely with everything. Now, I don't hope that your kids will have sulfuric acid at home, by the way. Now, easy for at home and safe for the youngsters, doing the dishes, the warm and the cold water effect, soap in a fatty pan, making bubbles. Many kids like to make bubbles. And making these bubbles, letting them blow bubbles, they can find out a certain ratio. Do I use only water or only soap? What is the best ratio between both of them? And we can teach younger kids already which one makes the best bubbles. And they will see that in a certain ratio, these cells, they connect well to each other. These molecules stay together. Now, ice and water, melting ice, we all know how that works. Condensation on the outside of a glass. Explain them the little story about the water droplets going slower. And of course, the water in a straw. Young kids here at TK already do this. They pick up water with a straw. There's a pressure, the pressure cannot get away. There's a vacuum which holds it up, and we can transport it. Oh, what happens if we do this with a glass or something bigger? What happens when we take a tumbler? And we can teach students how this works. How much water can we suck up into a straw? Can we put a couple of straws together? How far can we suck water away from a certain spot? Will the water keep on flowing if I put a straw at a lower spot? And these games are quite easy to make at home. They don't cost a lot of time. You can make them in the shower, so only the shower will be wet, and the students can play for a while. They can work with these things. Okay, next page. Now here we have, of course, the cola experiment. It's in slow motion. Now what happens? We are putting Mentos in it. It has a lot of sugar. Now normally soda will react with oxygen. Bubbles will come out. And what do we do with Mentos? Mentos is a kind of a catalyzer. It makes things work a little bit quicker. Now this is really slow motion. Now what happens? The Mentos goes in. It's a sugar and it makes a lot of foam. It's reacting with the oxygen outside. And what happens? We have a big pile of foam. Now do this outside, inside, everything will get sticky. This is a really simple thing to do with a student and really fun as well. Now, what can we do to change this? We can make little holes in the side of the bottle and it will spray out in different ways. Now, another one, which is more for secondary students. Let's move this one a little bit. 3, 2, 1, go! Now, this is a little bit too big. This is the elephant toothpaste experiment where we have yeast, hydrogen peroxide, and soap. Now, the yeast makes the hydrogen peroxide evaporate really quickly. The soap will make all the bubbles, and we can put coloring agent in it as well as here. So what happens if we pour the yeast inside, it really starts to make a lot of bubbles. But because of the soap being inside, the bubbles don't break anymore. So we get a gigantic big amount of bubbles, and we call this elephant toothpaste. It is doable at home. It is not that hard. Most of the ingredients can be bought at the normal supermarket. For yeast, don't take the powder form. There's a liquid form as well. It's a little bit better. And for chemistry, we can also teach them yeast and how it rises, how bread becomes bigger. Okay, let's take this away. How to put you back on this side. Okay, now physics. I teach physics here in grade 10. It's my main subject. Is it all abracadabra? Now, physics is actually nothing else than using mathematics to explain things in biology, to explain the world around us. So for physics, they need to have mathematics skills. Otherwise, they're stuck. Now, physics is really wide. If you look at my physics books as well, they have so many different aspects. Electricity, forces, balance, energy, and power. How much energy can I get from 1 teaspoon of carbon? Light, sound, the universe, and the atom. It's extremely wide. So at home, we can do many different things with physics. Now, for things to do at home, electricity. A simple trick with a battery is to throw a battery in water. Now, a battery has an electrical current inside. And what will happen here is what we call electrolysis. Water is not an element. Water is made from hydrogen and oxygen. And what happens here? One side will start to make bubbles. We have hydrogen coming out. We can catch this hydrogen. And the other side of the battery will become a little bit rusty. They are reacting. So one side is actually going away and the other side is making gas. But where do these bubbles come from? The child will look at this like, hey, there are bubbles coming out of the matter. out of the metal, and they don't know how this works. So we can show them that it actually is dissecting water into two different elements. We can capture the hydrogen by putting a small tube on the bubbly side. We capture it for a while, we take the tube off, we turn it around, and we put a little fire to it. Now, what happens is we hear a popping sound from it. Hydrogen burns better than oxygen, and it will give a small explosion. It does not blow up your home, don't worry about it. And we can show them that there's actually not air coming out, but something completely different. Now, forces and balance, making toys balance on top of each other. We have a couple of balls. Let the balls be on top of each other. Can a kid do this? What if we put three different sizes of balls on top of each other and we let them drop at the same time? These forces, these elastic forces, all go to the bottom ball, and from the bottom ball, they push them all the way up to the smallest ball again. And the kids might see that the smallest ball can fly away really far. Energy and power. Do we do things smart? Who is stronger? Or do we need to ask who is smarter? For energy and power, we can teach young students that with putting a fulcrum, a lifting point at a single spot, we can make work really easy. I can actually lift up a car with one hand. I need to have a really long pole, a fulcrum which is really close to the car. A fulcrum is a turning point, and I just pull on the long pole and I can lift up a car with my hands. The amount of force on one side multiplied by its length is exactly the same than the amount of force on the other side multiplied by its length. And in this way, we can lift up things, really big things, with using your brain. Now, with light, mirrors, and lenses, our sun, looking at how our sun goes around the world, make a sun clock in the garden. Let them go out every hour and see where the shadow of the sun is. Now, mirrors and lenses have a light somewhere and let the light go through a living room. You can do this in the evening, it's already dark at 6. We can put a couple of mirrors, we can stand there with a few people, and we can let light travel through our room. We have one flashlight, and it's a challenge for them with placing a couple of mirrors to let the light go all the way to another spot. Let's say they need to have light under the bed. And with a couple of mirrors, they can make the light travel somewhere else. Now, with lenses, of course, we can magnify things. The biggest problem I have with lenses is kids playing with these outside and they want to take a look at the sun. Now, that's the last thing their eye will ever see. So, if you use lenses, be sure that the students will never take a look at the sun. A bottle instrument, sound. We can have a couple of empty glass bottles and they all make a different sound. If we put some water in it, we can get different tunes. Can they make a xylophone of a couple of bottles? Can they make their own music instrument? They are playing, they practice what they listen and what they hear, higher and lower tones. They need to connect them with each other, maybe have a piano next to it, and they need to make a certain noise. Can they make their own instrument? Can they make the same sound as a piano? No. Here in Bali, we don't often have beautiful night skies, but looking at the night sky, the movement of the sun and the moon, Saturn, which is often visible, Jupiter and Mars, we have apps on the phone which can show you where certain stars and planets are. We can teach our students by taking them out once a week that the stars are still at the same spot. The moon changes shape, it's actually not changing, that's getting day and night on the moon. And we can also let them take a look at the movement of the planets, and they can see that the planets move along a certain line. They're moving all year long. Now, the last part for today is biology. Now, kids often have the view of the world that we are the boss here. We are humans, we can cut down a tree. It's our world here. But actually, we are not the boss. Nature will always be boss. The world can easily live without us, but we cannot live without this world. Now, especially now with this COVID virus, we see like how a little thing, a little virus or bacteria can change the entire world. The whole world is in panic. People are dying everywhere. Healthy people get sick. We need to change how we live. We need to change how we travel. We need to change our social way of communicating with each other. We even change our school systems. Now, let our kids learn that we are just one small thing here on this planet. There are way more other animals than humans. Now, what kids can do at home, exploring the garden. Take a look, what is growing in the garden? Can we find any bugs? What is in our soil? What kind of leaves do we have here? There are not many poisonous animals here, so there is not much to fear. But we can let them gather a couple of leaves from the garden and compare them with each other. Why is one leaf really fatty? Why is the other leaf so dry? One leaf is really big, the other one really small. One has a nice and smooth on the outside, and the other one is hairy. Why do leaves have a different color? Why do plants have a different color? Why do flowers have a different color? Let them explore. Let them see what our nature has to offer. We have nature everywhere, and often we don't even look at it. We keep it at our side and we're not doing anything with it. Now, death and decay, the nitrogen and carbon cycle. Now, when I was studying, we every week we had a new product in our kitchen. We were living with guys, all guys, and we would put a piece of food there, being an apple, a radiated apple, and a normal apple, or be it a piece of bread from the McDonald's and a piece of bread from the baker. What happens after a week? Are they both actually the same? What changes do we see? On a piece of bread, after a week, there will be molds growing and fungus. If we take a magnifying glass and we look at this, we see that it's actually not so yucky, but it's a beautiful garden of really small organisms. We often think that death and decay is so disgusting, but we are death and decay. We will die one day. We will decay one day. Everything that we eat, it also changes shape and form and it comes out on the other way. We are just as much part of the nitrogen and carbon cycle than anything else on this planet. Maybe even more because we use all these products again. We use all the manure of the animals. We spread it on the land and we let plants grow from it again. Now, things what we can do at home as well is growth. What does a plant need? We take a couple of small plants, mostly tomato plants, grow quite nicely. And when they're all the same size, we put them at a different spot. We put one outside in the sun, we put one outside in the shadow. We put one inside, still at a bright place, and we put one in the closet. What happens between these plants? Why does one grow better? Why does one get a different color of leaf? Maybe we can change something else. We give one water and the other not. See what happens to a plant. What does a plant need? What does a plant need to survive? If we teach this to our youngsters, we already teach it in grade 1 and 2 and 3. But if we teach this to our youngsters, if they can see it, if they see progress every day, they might know a little bit more about this. And for us, it's quite easy to do. We just put a little seed in the ground and we put it there and we just wait a while. It's not that much work to prepare this. Now, digestion, we are what we eat. Students often forget that if we eat things with a lot of color, this color needs to go somewhere. If we drink, let's say, you have Mountain Dew, which is quite famous in America, and these have a lot of coloring agents inside. When we go to the toilet to take a pee, we will see that all these coloring agents are not taken in by our body, and we actually pee them out. If we drink the blue Mountain Dew, we will see that after a while we will have blue pee as well. Now, other foods with a lot of coloring inside is, of course, red beet mera. If we eat this, we will notice, if we eat a lot of it, we will notice that it comes out in a way as well. We are what we eat. If we eat fatty things, this fat needs to go somewhere. If we don't exercise a lot, it's not that healthy for us. If we eat a lot of fruits and vegetables, if we eat a lot of onions will react in our body. These cabbages, they will make a lot of gas. Does this work the same with the other way? What happens to us when we eat a whole week only vegetable? What happens for a whole week when we eat a lot of meat? Will it change our digestion? Will it change the way how we feel? Now, for grade 1 until 3, this is still a little bit hard, but for grade 4 and above, they can already do some self reflection. What do I actually eat? Is it healthy for the world that I eat these things? Where does my food come from? Where does my vegetable come from? Where does my meat come from? Is the animal being treated well or not? Or we don't mind. Meat is meat. Some people have a different opinion about this, and some people will really look at it. Now, the path of a tomato, the last part, from flower to fruit. What students often forget is that the flower of a fruit is the reproductive organ of the plant. It's what defines it between female or male. So if we look at a tomato plant, if we see that it's getting fertilized, pollinated by bees or by butterflies, in a while the flower will die and we will see that from the flower it grows a fruit. The same as fertilization between mammals. We get our fruits as our children. We can show kids by taking a picture every day or every 2 days that the flower is actually producing the fruit. If we have fruits like a fruit plants in our garden and they don't have flowers, that means there's a really low chance of them of ever growing a fruit. Does it grow bigger fruits when it's in the sun? What does it need to grow a fruit? A fruit is full of sugars. A plant makes sugars with carbon dioxide and water and sunlight. It's a reaction. What happens if it doesn't get any sunlight? Can it still make the reaction? Will it still make the sugar or will it die? Now, these are quite simple things which we can do at home. It doesn't need a lot of material, it doesn't need a lot of time. Some things need to be assessed once a day. It takes only 5 minutes. But for a kid to see these things will only help them when they grow up. Now, this was the last page. Let's take this one away. Now, I still have a copy. I still have a video of chemistry things we can do at home, but the video is a little bit long, so I'll place it in here. If I show this here in class, it just takes 15 minutes and it's a waste of time. If kids really like to do chemistry, if they see this as a fun way at home and you have the time as a parent to work on this, take the time with your child. Take the time to teach them a little bit more about the world. We only have our lessons here and the videos which we put in, and they will never be complete. But what students will be missing now they're at home is the connection with a teacher. We, as parents, will be the teachers for a while. Still, some kids will come to school, but many of the students they need to work from home. And this role as a teacher, we as parents need to fill this in. Please don't forget this with your child. I'm away often and with my own kid that she wants to read, she wants to exercise, spelling. And I was amazed that after a few weeks of me not being at home much, she can spell words already. I see busy seeing a shape and the letters, and she can say words already. Step, she's learning more and more. And our kids grow up really quickly. We need to be part of a student's growth as parents. Okay. Are there any questions? We still have a couple of minutes. A lot of students and parents. Let's see who are here. Doo-doo-doo. Are there any questions from any of the parents which you do at home with your children? Maybe you can share your ideas with us.
All right. Anyone who have a question? This is actually the last day. The last day with Pak Jelmer for the parenting's virtual camp. If you had any question, of course, you are allowed to unmute your microphone and start asking questions. Okay, since it's we have 4 minutes left and there's no more question, apparently it's very clear, Pajelmer. I mean, it's true what you have just presented. It nature and all that. It's basically facing daily. And what I think what surprised me, like what surprised everyone, is that as small as a virus or bacteria that you have explained before, that it would have, affected and influenced the whole society. Like that's crazy, basically. But anyway, we still have. I think if there anyone who have any more question before we move on into the photo session and then we end the session. So there is no more question. Let's have a photo session. So everyone, please turn on your camera. So we want to see your beautiful faces, even though you're staying at home. Please turn on your camera. Thank you. All right. Okay. All right. So are you ready? Okay. I'm going to be taking the screenshot. Going to be counting from 3 to 1. Okay. So make sure you have your best pose. Ready? 1, 2, 3. 1, 2, 3. Okay. Thank you everyone who have joined today's discussion. We still have another discussion tomorrow with either Ibu Sukma or Ibu Lydia for Finding the Soul and Journey to the Future on Friday with Ibu with another one. So we still have two more meetings for the parenting camp. Okay, so thank you everyone who have joined. I hope we
Thank
can
you
see you
everyone for
again
joining.
tomorrow.
Thank you, Pak Doni, Bu Ria.
Thank you everyone. Have a great day.
Be
Stay
healthy.
healthy. See you.
See you when I see you. Take care. Be healthy. Wash your hands.